We're going to look at doing some equations from the 7th grade math book, chapter 5. We're going to look at how to solve some equations involving parentheses. They do require a few more steps than your simple equations. So let's go ahead and dive in. Let's go ahead and say that you are given the problem 9x 9x plus 1, and you can see that there are parentheses there, equals 3x plus 8. All right, our first thing that we need to do is we need to go ahead and make these equations expanded. So for instance, if we're looking at the first part of this equation, we can see that there is a 9 outside of the parenthesis equation, or expression x plus 1. And we can use the distributive property to go ahead and move this 9 in here. We're basically going to be multiplying it throughout all of the terms within that expression. So that means that we can take this 9 and we can multiply it by x first, which gives us 9x. One thing that I try to reiterate over and over again to students is to say that anytime there is a number that is pushed directly up against a variable or some sort of expression in parentheses like this, that means that we can multiply. So we've used the 9 for the first part of our expression. Now we're going to do it for the second part. 9 times 1, we need to remember that 1 actually has an addition sign in front of it. So we're going to say 9 times 1 is 9. Both of those numbers are considered positive, so we're going to say plus 9 here. Okay, that's the end of that part. Let's go ahead and solve the other side. Same thing, distributive property. We can take this 2 and multiply it in to both of the terms inside of the parentheses. 2 times 3 is 6. And we're actually talking about 3x. Even though there is an x within that term, we can still multiply it by an additional, another value. 2 times 3 is going to be 6. And we know there's an x because we actually multiplied 3x. Now we can take 2 and multiply it by the next term, which is positive 8. Well, 2 times 8 is going to be 16 because there is a plus sign there and both numbers are positive. It's going to be plus 16 here. So now at this point we can go ahead and try to balance out these equations by adding like terms. Now, one of the things that I typically do when adding like terms is I go through and identify each of the terms by deciding which ones I'm allowed to put together and which ones I am not. So for instance, it would be kind of like separating from a bowl of fruit the apples from the oranges. Well, I don't have apples and oranges here. I have terms with an x and I have terms without an x or without a variable. So what I'm going to do is I'm going to underline in green the terms that have a variable that is exactly the same. Here's a 9x and here's a 6x. Those two have an x at the end. There is no other information involved there aside from how many of those x's there are. But because that variable is the same, I'm going to underline them in the same color. And now I'm going to use a different color to identify which other terms could be put together. So say, for instance, my green ones are my apples. Now I'm looking for my oranges. Plus 9 is just a typical numeral. I make sure that I use my pencil to go ahead and identify the plus sign in front of that. Here is another term, no variables involved, so I'm going to go ahead and make that one of my pinks or one of my like terms for that particular type of term. All right, so now what I'm going to do is I need to combine these somehow, and in order to keep equations balanced, I need to go ahead and make sure that I am doing the same things to both sides of my equations, and so let's go ahead and do that. I have a 6x over on the right side of my equation, and I want to try to combine it with my 9x on the other side, on the left-hand side of my equation. So just for the sake of remembering which is right and left, RHS is going to be the right-hand side. So we're talking about that entire section to the right of our equal sign, and this is going to be our left-hand side. That's going to be everything on the left of our equal sign. So right now I have the 6x. I'm actually seeing that there is no addition or subtraction sign in front of it, which means that it's positive. Well, in order to get rid of something positive, I'm going to have to subtract it. So I'm going to subtract 6x. And in order to make sure I am actually balancing my equation, if I do something to the right-hand side, I have to do it to the left-hand side to make sure that my scale is balanced, which, remember, an equation is really similar to a scale. The left-hand side is always going to be equal to the right-hand side. We're keeping them balanced. I'm going to move this over to this side. Same operation here. We're still keeping subtraction. 9x minus 6x, if I'm going to solve just that particular portion right here. I'm going to go ahead and box it so we can see. 9x minus 6x is 3x. I have a positive 9, and I'm only taking away 6 of those. Therefore, I'm left with a positive 3. The other part that we are going to do is, now that we have the x's on the left side, we're going to move all of the numerals without variables to the right side. So I have a plus 9 over on this left-hand side that I want to get rid of. Right now it's plus 9. If I want to get rid of something that I have an excess of, then I need to subtract it away. So I'm doing this opposite here. If I have 9 and I take away 9, I don't have any more. I'm going to subtract it on the same side, on the opposite side, but I'm doing the same operation, because if I do it to the left, I have to do it to the right, because I'm trying to keep these balanced. 16 minus 9, I know it's going to be 7. All right, so I'm going to rewrite my problem. From the left-hand side, the only thing that's left is 3x. From the right-hand side, the only thing that's left is 7. So now I am back to a simple equation. What I can do here is I need to get x alone. Why am I getting x alone? It's so that I can figure out what I'm multiplying by 3 to equal 7. Because remember, this side of my equation equals the same thing that this side is. So whatever x is, when I have 3 of them, it's going to be the same as having a 7. So now let's go ahead and look at this. Right now I have times 3, so we're asking what times 3 equals 7. I can't do that off the top of my head, so I am going to go ahead and follow through with the steps. I am, instead of multiplying here, because 3x means 3 times x, I'm going to divide by 3. Why? Because I want to move that 3 to the other side. I want to break those 3 groups into one group so that I can get x alone, 1x alone. 3 divided by 3 is going to be 1. We never write a variable with a 1 in front of it, so we don't need to do that now. We're just going to go ahead and make it look like they have canceled out. And if we do it to the left, we have to do it to the right. What's left now? I rewrite my problem. X on the left-hand side, 7 over 3 on the right-hand side. This is an improper fraction. If I were going to write it as a proper fraction, I would go ahead and divide my 7 by 3. It's kind of like you're kicking that denominator out to the left to be the divisor. And what we're really looking at is 7 divided by 3. 7 can have 2 groups of 3, 2 full groups of 3. That means that we're using 3/6 of whatever it is that we are counting. 7 minus 6 is 1. We are left with 1 out of 3 needed for a whole. So x actually equals 2 1/3.